Hello everybody and welcome back to another Golang tutorial. So in this video we're going to be talking about variables and data types, which in my opinion are some of the most fundamental and important aspects of any programming language. Now there's a ton of different types, there's a ton of different ways to make variables and access them, so I'm going to be showing you the most common and most important ways here. In the next video I'm going to go into more detail, so if you think I missed something, hold off, I'll probably cover it in the next video. Okay, so what we need to do to start is understand what a variable actually is. So in programming, we have variables. What a variable is essentially some way of storing and accessing information. So it's going to hold some value for us. We may manipulate that variable, so change it later in the program. We may use it somewhere. We may pass it around. But the idea is it's just kind of a slot that stores some type of information. So using the classic example from your math class, you often saw variables like x, right? Maybe you saw x, y, maybe you even saw z if you got crazy in 3 dimensions. But if we have x, maybe you saw something like x equals 5. Now, if I write the equation x plus 5, you can tell me that this is 10 because you know the value of x is 5. Now, this works very similar in programming, except what's on the right side of this equal sign might not always be a number. So we might have a string, which is something like this, right? We might have a character. We might have a byte. We might have a floating point number. There's different things, and what's on the right side is actually what's known as a type. So we have some type that goes on the right side of our variable, and that type is very important in a language like Golang. So if you've worked in languages, I want to say like JavaScript or Python, you may not be super familiar with the notion of statically typed languages. What that means is once a variable is declared to be a specific type, it cannot change. So if I make the variable x and I say that that variable is of type number, now that's not a real type, but we'll talk about that in a second, then it can never be of type string. It has to be of type number all the time unless we redefine that variable or we, I guess remove it and recreate it or something like that. But that's the idea in a statically typed language is types do not change, whereas in a dynamically typed language, guess what? They change. So that's the idea. Now to make a variable, the syntax is var, so that's the var keyword, the name of the variable, which can be anything. I'm going to talk more specifically about this, pretty much anything you want, but it does have to follow a few rules. So it has to be comprised of only letters, numbers, and underscores. Those are the only 3 characters you're allowed to use. It may not start with a number, and it may not contain any special characters or any spaces. So a valid variable name is something like Tim underscore name2. That's fine. Time underscore name2. It has an underscore, it has a number, it has letters, that's okay. A valid variable name is Tim. A valid variable name is Tim underscore. A valid variable name is Tim underscore 1. An invalid variable name is 1Tim because it starts with a number. An invalid variable name is Tim hello because it contains a space. An invalid variable name is Tim slash hello because it contains a slash. That's the idea. Just follow those few rules, only numbers, letters, underscores, no spaces, cannot start with a number. You will be good to go. It also cannot, I believe, be a keyword. So I don't think I can name a variable import. I think that will cause a problem. So stick away or stay away from naming your variables anything you would typically see, like func, FMT, main. Like you probably don't want to call it those things or you'll run into issues. So I'm just going to make a variable here and I'm going to call this name. Now what I want this to be is of type string. Now notice it's actually showing me the suggestion here already, but what you do is you type var, the name of the variable, the type of the variable, which we'll get to in a second. In this case, I'm going to type string. You put an equal sign, and then on the right-hand side, you put some value, some text, some number that corresponds with the type you picked. So in this case, I pick string. So that means on the right-hand side here, I need some string. So I need something inside of double quotation marks. Now it can be just the double quotation marks. That is still a string. That's known as the empty string. But I could do something like hello Tim, and this would be valid. I have now just created the variable name. This is of type string, and it stores the value hello Tim. That means if I print out the value of name, it will show me hello Tim because that's what it stores. That's the basics with variables. Now there's a few other ways to do this. In fact, what we can actually do is say, well, I want to make a variable called name that is of type string, but I don't know what value it's going to be yet. So what you can do is define that you want to make a variable called name of type string, and later on in the program, so below that line, you can type something like name equals Tim, and that's fine. What that will say is now name is assigned the value of Tim. And if you want to change this later on, you can say name equals, let's say, Bill or something like that, and that will change the value of name to be Bill. That is the basics of how a variable works. They're not too confusing. Now, there's a few other ways to define variables. I'm going to talk about that in the next video where I talk about implicit versus explicit declaration or assignment, but that's the idea. These are variables. Okay, so now that hopefully we understand variables, I'm going to show you a few different types that we can set for our variables. Because remember, we have var, we have the name of the variable, and then we have the type, right, that goes here. So we need to know what types we can have and what those mean and why we would use them. Okay, so the types. So I actually wrote a little thing here just to show you. I just stole this from the Golang site. We have numeric types. We have kind of string types, boolean types. There's a bunch of different ones, but we're going to go through them one by one. So the first type of types, now I know this is weird, but like I guess category of types we have are integers. So these are some kind of integer values. They can be unsigned, signed, or machine dependent. And let's go through all of them. So the first type is uint8. Now that stands for unsigned integer with 8 bits. Now what is a bit? Well, a bit is simply a 0 or a 1 represented in the computer, right? So all your computers represent information in zeros or ones unless you're using a quantum computer, I believe. Yes, I think so. Anyways, in standard computers, zeros and ones. So with 8 bits, otherwise known as 1 byte, which is another way to refer to uint8, you can represent the values at 0 to 255. Now the U stands for unsigned. Unsigned means this is not a negative value, this is a positive value. So with 8 bits or 1 byte is 8 bits, that's what it means. You can represent a number between 0 and 255. So if you want to have a small positive number, you would use the type uint8. Okay, uint16. Straightforward, this is between 0 and 65535. Notice that all this has done is added 8 bits to our representation, so how much space this variable is actually taking up, which means now we can represent a much larger number, which is actually 2 to the 15 minus 1, I think, or 2 to the 16 minus 1. Like, if you do that exponent, I think that's what 65,535 is. Anyways, I might be wrong about that, but I'm pretty sure that's right. Okay, so now we have uint32. Now again, all we've done is we've added 16 more bits, and now this is the number we can represent, which is exponentially larger, and we go down to uint64 and same thing. So these are the ranges I've written on the right. Notice that uint8 and byte are the same thing. So you can write either byte or uint8, they mean the same thing. Okay, now we come down to signed integers. Now signed integers are pretty much the exact same as unsigned integers, except they can be negative. And all that means is the first bit of our data now, or of the number, is actually going to represent whether it's a positive or negative number. So here, notice that uint8 represents from 0 to 255. Now we represent from negative 128 to 127. So if you actually count the values, that's the same number of numbers we can represent, but the magnitude is different because we have the ability to represent negative numbers now. So that first bit we need to use for either a negative sign or a positive sign. I believe 1 means negative, 0 means positive. So notice that it is 128 numbers magnitude less, right? And that will be the same for all of these. Somewhat, yeah. So now we'll go to int16. And notice that this again is smaller in magnitude than this, but it represents the same values. And that's because it's 16. We need that first bit. Int32, this is known as rune. So same thing, you can represent int32 with the word rune. Represents these values. Int64 represents these values. So typically, you don't need to use more than int32 or more than uint32. Now, it's common to just type int64 because our computers have so much memory and space now that it doesn't really matter what data types we're using in terms of the magnitude of them, unless you're writing a very memory efficient program. But what to keep in mind here is if I write that my variable is of type uint64, that means I'm gonna use 64 bits to represent it no matter how big it is. So even if it's only the number 1 or it's the number 0, we will still take up the same amount of space as a number that looks like this. So that's why it's a good idea to use a smaller bit number, so like uint 8, if you're going to represent smaller numbers, because you will use up less space in the computer. Okay, so now we're going to go to machine-dependent types. So machine-dependent types are just things that you can type and your computer will automatically kind of figure out how big these are supposed to be. So if you type uint, what this will do, and I believe it actually looks at if your operating system is 32 or 64-bit, it will use 32 bits or 64 bits to represent an unsigned integer. So it's common that you'll see people just type uint or int as their type, and that means that based on the OS they're using, it will either be 64 bits or 32 bits. So this is the exact same as uint. It will be 32 or 64, and then uint ptr. I mean, you can read this definition here. I'm not really going to describe exactly what that is. I feel like that's a little bit above and beyond the audience here. Okay, so now we're on to floating point numbers. So the types here are float 32 and float 64. Now it's common just to use float 64, but again, this is the same thing. So this means a floating point number, so some kind of decimal number with, in this case, 32 bits of precision. So we're using IEEE 754. If you know what that means, great. If you don't worry about it. And this is a 32-bit precision number, which means we're going to use 32 bits to represent this float. 64, same thing here. Now float again stands for just some decimal number. Like if you add a decimal, immediately becomes a float because we need to represent those decimals with some level of precision, either 32 or 64 bits. Okay, then we have complex types. Now complex types involve an imaginary part. I'm not going to talk about complex data types because we're probably never going to use them. In fact, in this series, I will tell you right now, we're not going to use these. But if you're in physics or you're doing some computational math, some more advanced things, you will likely need these: complex 64, complex 128. So you can read through that definition, but pretty straightforward. Strings, as we talked about, anything in double quotation marks. I didn't add this in here, but characters are anything in single quotation marks. And then Boolean values are either a true or a false. So a Boolean just tells us this is true or it is false. We're going to use those a lot in this series. And these take 1 bit. So true is 1 and false is 0, but we just write true and false to represent that in our program. All right, so that's the basics of types and data types. Now let's just define a few variables of different types, and then we'll pretty much be done with this tutorial series. So let's make some int. Let's say var number, uint, let's see, uint equals, and actually let's do 260 and see what happens. So I'm going to make this uint 8, and we'll make this equal to 260, which is out of the range of uint, right? So look, uint 8 is only up to 255. Let's save this. And let's actually run this and see what happens. So notice that I'm actually getting this squiggly value here, and it says overflows. So that's telling me that this here is too big to fit into 8 bits. So if I change this to 16 and we hit save, no more errors, we're good. But wait, what's it saying here? Number declared but not used. So whenever we declare a variable in Golang, or in fact, whenever we declare anything for that matter, if we don't use it, that's actually an error. So if I don't use number in some capacity, then it's actually a problem. We're not allowed to declare it unless we use it. So actually, let me show you how we can type or display this number. So I believe I can actually just do comma and then put number here. And now what's going to happen is we're going to print hello world, and then we're going to print this number 260 afterwards. So let's open up that console if I can find this. So let's go view terminal, back to full screen, and let's do go run tutorial and see what happens. Okay, so hello world 260. So that's the basics. That's how you can print out the value of the variable, is by doing 260. Now I can actually go ahead and do something like number equals number plus 5, and we'll talk about arithmetic operations later. But if I do that, this will change the value of number to be 265 because we'll add 5 to it. So let's save, let's run this down here, let's hit enter, and now let's see what we print out. We get the value 265. So when we're printing things out with println, we can separate things by commas and print multiple values. We can print multiple variables if we want and just display things, but I think that I'm going to leave the tutorial here. So that's a little bit about types and about variables. Hopefully this made sense. I go very in detail with these things just because at the beginning, I really want you to understand how all of this works. And yeah, with that being said, I hope you enjoyed. If you did, make sure you leave a like, subscribe, and I will see you in the next Golang tutorial.